All right, let's get going. So my name is Nader, and today I'm going to present a Python code focusing on mimicking the functionality of a smart doorbell. So I'm going to talk about how I decided to mask an area of interest, how the code works as a whole, how I decided to make some of the decisions that I did throughout the process of iterating, whether it be through thresholds, kerneling sizes, all that jazz. So then I'm going to reflect a little bit on my experience with the project and what I think could be implemented to make it better. So I'm going to dive into the code. So this code is pretty heavily commented. If you have any further questions, hopefully those can assist you all the way if the video moves too fast. But I'm going to walk through the code in chunks just to give an idea of what's going on here, and it will be readily available if anyone needs to come back and reference it. So first, lines 4 through 9, we're importing the necessary packages. Lines 11 through 20, that's a function applying a mask to the camera. So we're going to crop out data that's not important, gray that data, and then blur it so that we can easily detect if a person has entered the frame or not. So moving down to the main function, we got some initializations happening, defining the camera as the variable room. So this is us initiating the camera opening. We're going to set the width and the height of the camera with room set. And then we're going to apply time.sleep3, which will give the camera 3 seconds to adjust to the lighting of the room. So this will ensure that we don't detect something that wasn't really there, but the camera was just adjusting because it's initially turning on. All right, so lines 31 through 33, those are just some logistics for creating the video, and then for the email that will be sending the images to any email that you enter within the code. All right, so moving on to this big while loop at line 35, it's going to loop through until the entire video file is played. So it's going to loop through forever in this case because we're using the camera and the camera is ongoing, going to be open. But you could implement a video as well and then change some of the settings from camera to video. But moving forward, we're just going to grab the current frame of the camera, and then lines 39 through 42, we see some specifics on how to create a unique timestamp. So this will be used later so that we can create unique images every time when we're sending emails to the user. So then at line 44, we've got if counter equals 1, so we initialize that counter a little earlier in the code. This will assign the camera frame as frame 1. So moving forward, we're going to take that image 1, we're going to apply the mask to it so that the detection algorithm can be run later, and then it's going to add 1 to the counter so that when it loops through the next time, it'll assign the frame as frame 2, as you can see here in line 51. And then again, we're going to gray the image 2, and then we're going to reset the counter so that it'll pick up image 1. So that counter variable is really just helping out with pick frame 1, pick frame 2, pick frame 1, pick frame 2, so that we're continuously comparing the two. All right, so we're going to keep moving forward. We've got a pixel threshold that is 50, and we're going to initialize the total value detected so that we can calculate that later in the code. And we're going to create an array of zeros with the same size as frame 1 and frame 2. All right, so now that we've set the pixel threshold to be 50, which I'll dive a little deeper into later as to why I chose that threshold to be 50, and we initialize the total value detected, as well as creating an array of zeros with the same size as frame 1 and frame 2, we're going to dive into the actual pixel-on-pixel comparison. So that's what lines 59 through 62 do. It runs through the height and the width of the resized frame 1 and frame 2, and then it's going to walk through each pixel, and it's going to compare each pixel value to each other. And if the pixel value from image 2 minus the pixel value from image 1, the absolute value of that, so just the difference, is greater than the pixel threshold, then we will replace each pixel with a white pixel to aid in detection. So as we're detecting a difference, we're going to replace that difference with a white pixel instead of what it actually was, so that we can add all the values within that detector array, and we can determine if there has indeed been an object detected or not. So moving to line 65, we calculate the total detected through summing all of the values in that detector array that are collected throughout this loop. And then that is what we're going to use later to, again, aid in determining if an object has actually been detected or not. So we have this threshold of 500,000. That's arbitrary and can be changed to be more sensitive, less sensitive in different cases. But this is what works for my door. So if the detect totals, so that's the sum of all of the white pixels, from lines 59 through 62. If that value is greater than 500,000, then we will deem that an object has been detected. So it will print object detected. That's just for the later demonstration part to have clarity at which part of the code we're at. And then the first image and the second image that will be sent to the user's email will be created in lines 70 and 71. And we want these images to have unique names because if something else is detected, we don't want that image rewritten. We just want it resent. So in order to have to continuously have unique names, we incorporate this out string right here, which incorporates the current time, which is going to be unique every time that this code runs. Then we're going to initialize the timer variable to 0, and we're going to prepare to record a video. All right, so as we're preparing for the video, we're going to initialize the timer variable to 0, and we're going to determine how long we want the video to record for. So that's what line 74 does. This can be changed dependent on the duration that you want the video of the object detected to record for. So say an object is detected and I only want a 10-minute video, a 10-second video, I can change this variable to 10. But for now, I think 25 is appropriate to see what that person is doing and get a feel for what's going on at your door. And then here for record duration, we multiply the number of seconds that you're looking for your video to be by 30, since there are 30 frames per second. All right. Then we create a video with a unique file name based on time here. And then we can see width, height, all those good things, frames per second, variable that we defined earlier, deeming it an MP4, all those good things. All right, so moving to line 79, this is how we're going to set the video to write for a certain duration of time. So that's what lines 79 through 82 do. It just continues to append the frame to out and then to the variable out, and then it's going to collect all of these frames and create a video for a certain amount of time. And then we're going to increase the timer by 1 each time so that it continues to count. And then once that timer reaches the record duration, so again, this record duration is going to be multiplied by 30 because 30 frames per second, we will save the video to the device once the timer reaches the desired number of seconds the user wants the video to be. And then we're going to reinitialize the timer to quote-unquote rinse and repeat the detection process. All right, and as we reach the end of the code, now we're going to email not necessarily the video, but the 2 images to the user. So you could email the video. It just, as discussed previously, it could be a lot of data getting to your email. So we're just going to save the video for now, but totally possible to just add it as an attachment here to your email. And then here with this code and the YA Gmail package, you can send an email to user of your choice. So line 89, you're deciding who you're going to send the email to. Line 90 sets the subject of the email. 91 includes the contents of the email. And 92 refers to the attachments. So we determined these earlier up here in lines. We wrote these images based on the frames that have a difference in line 70 and 71. And now we want to email those to the user here in line 92. And then just for clarity's sake, when I run the code in a little bit, printing email has been sent to notify the user of this code that your email has successfully been sent. And then room release, we're going to release the camera, and then we're going to restart this process all over again. So this code should run infinitely. Okay, so I'm going to activate my workspace. I'm going to call the file, and I'm going to run it and walk through the door. So I've walked through the door and I have been detected. Throw up my arms, toss out some peace signs, thumbs up, all that good stuff. So now it's going to halt on object detected, and right now it's recording a video of myself. So once the 25 seconds has passed, then it's going to email those photos to my email, and it's going to save the video to my files. So we're going to see all of that. Right, so I'm going to quit the code. So we see that the email has been sent and I've been detected. So now we can go to my files. You can see the most recently detected video. It is currently 9:18, so this makes sense with the time. Then if I open it, make it a little smaller, you can see my hand shoot up. We can see that the time is appropriate, so 25 seconds. There's my thumbs up, the peace signs, and some of the explanations that I was giving earlier. So I'm going to let this video play out. That's just what it detected once I walked through the door. All right, awesome. So now I'm in my email, and we can click on this. It says that it's been sent to me because throughout the app, I sent it to myself. So here we can see the two images of me walking through the door, and they were sent with this message. An object has been detected at your home. Please refer to the two images attached to this email. So the next part is discussing in detail my approach to sensing someone or something entering the user-defined area and how I might improve this algorithm in the future. So walk through the entire algorithm with you guys already in the code, but to summarize it, I activated my camera, pointed it in the direction of my interest. So my interest is my door over here to my bedroom, as you could see in the past clip. So that was my area of interest. And then, actually I'm gonna hold it back up again. I applied a mask to where it cuts out my bathroom door, and I've got some decorations here, but I'm not interested in that because when someone's walking in, they're gonna walk in right here, and this is the primary area of interest. So I cropped out everything else by applying a mask. I walked through the gray and the blur so that the person can their pixels can be consolidated and easier for detection. So that was my approach for that. Comparing the pixels between the frames that were collected from the camera, that also helped me detect if a person or an object was sensed. And yeah, so improving the algorithm in the future, I think holding a history would be really useful. And I know in previous assignments, it had been a requirement to upload the video to Dropbox and then send the user a link who's receiving the email. So I think that would be really awesome. I know Ring implements that currently in their technology. So being able to have access to an online forum where I could save that video and the user could access it would be very useful. I think that would be really awesome to implement. And then as discussed earlier with my professor, Dr. Mitchell, sending somebody that video is a lot of storage in your email. So that's why we only decided to send the images for this assignment. But yeah, moving forward, improving the performance algorithm, I would definitely incorporate somehow saving the video to an online platform where the video can be viewed by a link. And yeah, maybe some minor touches here and there, and incorporating some type of software or hardware that can do automated camera adjust would be really awesome for this application. Did I change anything in the detection pipeline from what we covered in lecture to enhance the performance of my algorithm? So if I pull up what we covered in lecture, this is specifically for upper level tech elective at the University of Maryland, so related to an assignment. But I'm going to keep going. So our original detection pipeline for this assignment was to grab a first image and mask it, which I followed. Grab a second image and mask it, followed that with the if and then the else statement. Comparing the first and second image, that's where I set that predetermined pixel threshold and compared both of the frames. And then if the detection is made, so if the detection total that we covered earlier in the video was greater than a certain threshold, I would record in this case a 25-second video, and email the first and second image to the user, and then rinse and repeat. So I followed that detection algorithm pretty soundly. The only thing that I would say could be a little different is I entered in a content to the email that I'm sending to the user, so more friendly. Rather than just sending an email, it was saying, hey, this has been detected at your door, please refer to these images below. Other than altering the contact, that's the content. That's the only thing that I can think that I changed about the detection pipeline. It was very useful, pretty easy to follow, and it made a lot of logical sense. So sticking to that was definitely good. And if I have any recommendations on how the algorithm might be improved in terms of hardware and or software, I have heard of other courses utilizing Raspberry Pis to do similar things. I think that would have been super awesome to work with. Raspberry Pi are capable of so many things, so getting my hands on one of those would be really awesome to try to incorporate this code. I saw a lot of videos on it, and that just definitely would have improved the algorithm, whereas I could mount the Raspberry Pi in the placement of where I want to detect, compared to my computer's pretty luggy, kind of heavy to carry around, so activating my camera on that is definitely harder than it would be with the Raspberry Pi. But as for improving the algorithm, maybe again recording a history somehow of the camera but not taking up too much storage, and then maybe rewriting that history could be useful down the line if you want to just access the camera at any time and start a recording at any time. Maybe it could be a user activated, say if the user presses this button, just show them the camera, just show them the live stream of the camera. That could be something really cool to incorporate. I know my family at home, sometimes we're just checking, oh, did we close the garage door? Did we leave this out in the rain? And then we can just click on our Ring camera on the app and we can view it at any time. So that would be really awesome to incorporate in this code. And yeah, if I had to make any changes within the software, that would be it. And then the hardware, the Raspberry Pi. So discuss how I determined my kernel size. So when determining kernel size, it was the best just doing trial and error. I started around 11 and then made my way up to 13. So let me just confirm that. Yep, 13. So 13 was the best for me to mitigate noise while also not mitigating noise so much that everything was blurring together and just becoming one image. So after some trial and error, 13 for the kernel size definitely worked best for me when collecting all of those pixels. So now looking at how I determine my detection threshold values. So I'm going to talk about the detection value first. So when I was detecting the difference between the pixels, the main thing that I did was I took two images and they were slightly different, so kind of mimicking a door opening, and then I observed the pixel values of those, and then from there, again, kind of some trial and error, I decided what the proper pixel threshold would be. 50 worked out really well for me, especially since the grayscale value is just one value compared to RGB. If you were to leave it in RGB, I guess you could take the average of those values and then determine something, but converting to grayscale was definitely the way to go, because say you're in or BGR for Python, say you're in BGR and you have a blue screen and then it all converts to completely all green. I know that's not very ideal, but say that it happens, right? Then the average of the values won't change, because you'll have 255.00 for blue and then 0.255.0 for green. So doing grayscale was definitely the best way to go, and determining the detection threshold value for the pixel comparison from frame 1 to frame 2 was definitely a lot of trial and error. As for the detection threshold value for the detector total, definitely had to play around with this depending on which room I'm in, where I'm testing at, what's going on. So again, trial and error, having that detector total value print out was very helpful for me when I was determining which value to use there. So I think to make this better moving on in the future, maybe something that could auto adjust to the sun. I know I mentioned this in my previous video when I was looking at lane line detection, how if almost like a camera, like a Polaroid camera, could auto adjust to the surroundings around it based on what time of day it is, the location predefined by the user, things like that. and the time delay between the first and second image. So this was critical. If there is no time delay, the images will come out the same. So I entered a time.sleep, and I believe I decided to go with 2 seconds. Yep, 2 seconds. So I did a time.sleep for 2 seconds. I did it within the while room is opened loop, so that's just to separate the frames. So adding it within the loop but not within like the definition of each frame, that helped me so that it wasn't really separating out the frames. It was just taking a second and then it was going. So when it takes that second, the frame is your camera. So if I'm right here and then I go like this and there's no pause between collecting the frames, it's gonna look, the frames that are collected are gonna look like this, because it's such a slight difference, right? But if I do that same motion and I wait 2 seconds, so here I am, 1, 2, there, then the frames will look super different. So adding that delay, 2 seconds just seemed to fit really well with my testing. I tested with 1 second, 0.5 seconds, and 2 seconds just seemed to show a useful difference in the photos. So all of my values were really just trial and error, with using my code, implementing it, and seeing what looked the best.